Hey everybody, and welcome to Sofox with the Arduino Starter Kit, and we are on 15 hacking buttons, the last exercise. Yep, if you go into the nice table of contents right at the start of the book, you find out we got the introduction, we had all our get to know the tool, the spaceship interface, levometer, everything involving all our servos and the light theremin. That was fun, and sound and piezoelectrics and zoetrope. And right at the last one, we're at hacking buttons. So it's actually been a lot of fun making these, and I'll definitely will probably try to upload some other Arduino videos after this, but this is going to be the end of the official Arduino Starter Kit series, and hope you've enjoyed, and hope you've learned something, and I hope you've had fun, because those are all good goals. So what's this one about? This one is basically introducing this little device called the Opto Coupler. Now the important thing to know about this is that this allows your Arduino to control devices that are completely separate from your Arduino. Now you might say, well, isn't that the point? Don't we take components? But I'm saying like pre-built stuff, like say this. Now I know what you're saying. So you're saying that I can control the Arduino with this? Well, that's what I'm trying to do. One button at least. But the idea is that I can wire up the Arduino with this. This will still be running on its own power supply, everything. But I'll use the Arduino to actually press buttons on this. Now, technically, if I say press buttons, well, then that's technically setting up a servo and pressing the buttons manually, but I don't think that that's what we're going to go for here. What we're using is an Opto Coupler. Now, with an Opto Coupler, it contains two parts to it. It contains a photoresistive, if you can see here, it contains a photoresistor on one side and an LED on the other side, all in this tiny package. And what this means is you can put an Arduino electric current through this, light up the LED, and then the resistance on the other side will go down. So for instance, you send a current on this side and it opens up a circuit on this side. So basically you're able to send commands to press buttons. Now because there's no direct connection, because it's the connection from this side to this side is only through light and it's one way, you can have different voltages. There can be completely different circuits. For instance, if you hook up an Arduino directly to a calculator, they might be different volts. This might run like at I don't know how many volts this runs at, but yeah, so that looks like a 1.5 volt battery or something. So if it was just that battery, it would be kind of hard to get it. It'd be kind of hard because the Arduino is at 5 volts, and either you could burn out something or you could shock something. It's just messy. But this Opto Coupler allows you to connect the two without like getting them to share their powers and causing any sort of confusion. I guess you could say it does feel a little like a transistor, to be honest, but it's thankfully it's even more disconnected than a transistor. With a transistor, you've got to really know what sort of resistance you're going for here. So let's get started in actually building this circuit. It's actually really easy. Let's just take our thing from our previous circumstances and take this out, and yes, we don't need this at all. So we get our Opto Coupler and we connect it. No, we'll connect it here since yes. So we've got it from two. So the key thing is that one of the sides goes to ground. Let me just make sure that's the right way around. You've got to damn. Okay, so the text reads up this way, and they seem to imply that that's the bottom, and so this should be the right way around. Hang on. Just make sure I get the sorry, excuse my language. Okay, that should do it. Next up, we connect the middle pin, the middle left pin to ground. By the way, the middle bottom ground pin just doesn't even properly exist properly. So that's ground. There we are. So middle pin to negative, and we connect the well, first of all we connect number 2 to up here, and then we use a standard 220 ohm resistor to connect number 2, sorry I put that into 1 by accident, number 2 to the Opto Coupler, because remember there is an LED inside the Opto Coupler. We don't want to burn it out accidentally after all. And now comes the other part, which is far more complicated. Now I like this calculator. Well, I kind of just got it. It was cheap at a hardware shop. But I'm afraid I'm going to have to completely damage it. I'm sorry, but there's no other way. I can do this. Come on. There we are. Yeah, I'm sorry I have to do this. This is the reason why you should probably experiment in low-cost electronics before you do this to anything that's even remotely powerful or remotely expensive. There we are. Yeah. You can do this. Here we are. Engage in wanton destruction of personal devices. Okay, so we got the actual button out, and here's where we got below it, the membrane. Let's just make sure this thing is still working first. So on AC, yeah. And when I press this button membrane, there we go, 333. I've chosen 3 as a reference to very obscure sci-fi reference. Well, to an... yeah, damn it. There we are. We're getting through it. We're breaking through, Captain. Okay. It's not even that an obscure reference. Actually, people will probably pick it up. Okay. So, give me a sec. So you can see the idea with 3 is that the idea with these buttons is you press a magnetic membrane and connect to the 2 sides of the circuit. So you can see it right there. If you like disassemble like remote controls or stuff like that, you'll see something similar to this. Boy, that's messy. And if you look at this pattern here, you can see it kind of corresponds to this one. So, you know, this is the sort of stuff that they go with. This is what they're expecting you to see. Now, I need to figure out which is the positive and how this exactly is laid out. Alright, so we've got that. Now we just need to make sure that we actually know how this whole circuit actually is meant to work. So let's press one against this black surface here and press the other against the black at the top, and there we are. Sorry, I'll give you a better view. If I press one, as you can see, there are 2 black things coming towards each other, and if I put one at the top and one at the bottom, I put one at one, let me see, put one there, yeah. So the idea is we need to connect the top to the bottom in order for this to work. Let's try that one more time just to make sure. One at the bottom, one at the top. Sorry, give me a sec. Yeah, okay. So let's get it. We'll get 2 cables from this. We'll try to make them longish cables at least, so that we don't get it. This one's kind of long-ish. Oh wait, no, this is a nicely long cable. So we go from here, and now I've got to get it to here. And where's the other one? Okay, I can't seem to find an appropriate wire, so I'm just going to do this. Yeah, this is... Okay, so I've got the wire. Need one here and one there. Okay, so I've got the two wires that can now hook into the button. I could solder them right now, but I think I'll just go straight to the code and just hold it in place. So here we have the Arduino Ide, and and now we go from hacking buttons to, hacking the logo to hacking buttons. So the code for this is fairly straightforward, like the thing itself. It's proving a concept, and pretty much that's all the code we need. So, const int opto pin equals 2, and setup, we set the pin mode of opto pin to output. And then all we really need to do is just send pulses, turn it on and off. Digital right, opto pin high, turn it on, and delay for about 15 milliseconds, which is just a very light tap. Digital right, opto pin low, turn it off, and then we delay. So right at the moment it has 21 seconds. That's a bit too much. Let's make it 4 seconds. Perfect. So that's really about it. We just compile this. Great. So that's compiled, and let's go back to actually what this actually does. So the idea should be is that every 4 seconds it sends a signal to this thing here that basically bridges this thing here. So if we don't need this. If we bridge the gap with these two wires, then every 4 seconds we should see another 3 being added to the display. So let's put one here and one here. And there we go. 3. 1, 2, 3, 4. Yeah, anytime. Wait, that's it? No, this is not how it's meant to work. This is like so simple to set up. If it's not working, then what? This is confusing. I've set this up correctly, haven't I? Yeah. So it's 2. The 2 goes through there, up here, through the resistor, through the top, and then through the middle. That's the right place, isn't it? Yeah, through the middle. Up, top, and then the middle. And I'm pretty sure, okay, we can do a quick test just to make sure that the, oh, I know, probably 15 milliseconds is probably too late. Let's change it to 1/10 of a second, or just over 1/10 of a second. It's the same problem the last one had. It was just, the delay was just too quick. Okay, cool, so now it's about 1/10 of a second, which for a calculator press of this size makes a lot of sense. So, first of all, let's quickly test to make sure it actually works, and we do this just by, so every 4 seconds it should blink very briefly. 2, 3, 4. I don't know. Anyway, point is, let's just get back to this, and this is definitely in the right things. So I put one at the top, one at the bottom. Okay, there we go. 3, there we are, 3. Oh, damn it, it's... Okay. Let's try this one more time. The idea should be that it should only be... The 1/10 of a second should only give 1. But I think my hands are vibrating a bit, so that's throwing off the calculator. Okay, there we go. Ah, damn it. Don't want glare in there. Maybe I should solder this, but I'm not sure it would hold up to actual solder. 1, 3, okay. Okay. One here, one here. 3. 1, 2, 3, 4. Oh no, my hand. Okay, somehow my hand's got this. Okay, this is definitely there, and this is definitely there. Okay, go. Okay, sorry, yeah. 1, 2, 3, 4. 1, 2, 3. Okay. Damn it. I'm doing something wrong here. I mean, it's just, I know it kind of works, but you know, it's not, it doesn't properly work until we get the nice, smooth, okay, that's it. We're going full on with this. We're going full on. No more pecking, no more playing little operation with this thing. Oh, for just sake. Gotta have a better scrubber than this. Pro tip: glasses repair kit. Not just if you, even if you don't have glasses, then these are great for tiny screws. Okay, yep. Okay. Eesh. Oh boy. Oh boy. Oh boy. Oh boy. Oh, wait, hang on. Eesh. I think I've already broken something. Damn it. It's all stuck and yeah, damn it. Okay. Well, so there's the thing that we were trying to access. You can sort of see it there. This is the membrane pad with all the little, you push these down, and these are just the buttons that press against the memory pad, that push the magnetic thing across these and join the circuit. I'm gonna have to. Okay, now I've got to take off everything with hopefully not breaking any of the wires. Even though I found a red wire here and I'm suddenly wondering where it came from. I didn't just imagine that, did I? There was definitely a red wire. Okay. So, yeah. Okay, so that's the light sensor, and that's the main display. All that's left is that's the main control system. And this is the battery, which we'll leave in place. Okay, so hopefully if you want to control your buttons, you'll either solder them properly or not damage the device as much as I just did. I just needed to get at the buttons. You know me. Yeah. Okay, so let's try to actually get this properly. We got 1 cent here and 1 part here. This is 1. We're doing 1 instead of 2 right now. There's 1. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2. Did I try that instead of for 5? No, I set it for 4. I'm just counting too fast. Okay, and I forget which AC was. I think it was, which one was it again? I think it was one of these ones. No, that's off. There, that's on. Okay, second left. Okay, so that was cool. Let's try this one. Let's try 2. Okay, so 2 right off the bat. 1, 2, 3, 4. Huh? I was doing it with 1. It was working like literally 1 second ago. Well, not literally. Okay, let's try again with this. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so that's working. Let's try it here. 2. 1, 2, 3, 4. 1, 2, 3, 4. Look at there. 1, 2, 3, 4. Okay, try this one here. 1, 2, 3, 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, wait, actually, I think that's because we reached the end of the display. I'll better reset everything. Okay, try again. 1, okay, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Great. So it is working. It is definitely working. Okay, let's try. It's working with 1 and 5. I didn't quite get it working with 2. Let's just check. Let's just check 3 one more time. Maybe I was scratching it too much. Is that always? It's interesting. If I make contact and it doesn't press the first time, then it seems to work. 3, 4. 1, 2, 3, 4. Okay, so it worked with 1, 5, and 8. But I'm having trouble getting it working with 3. 1, 2, 3, 4. 1, 2. Oh, 1, 2, 3, 4. I do not know what's up. Let's check 6. 1, 2. Yeah, 1, 2, 3, 4. 1, 2, 3, 4. Okay, cool, that works. Yeah, actually, wait, let's try to AC it just using the timer. 1, 2, 3, 4. Yeah, there we are. So, I don't know if I damaged this or what, but 3 just doesn't seem to work that well. Yeah, that's what worries me. Every time I tap it, for 3 it feels like the bridge is already closed. If I switch this to this, I don't know if it'll make any difference, but I'll give it a go. I don't get this. This is weird. Put this back. Every time I use it works with every button except 3. Oh, hang on. Try 7. Wait, first of all, we'll just check. Reset. 1, 2, 3, 4. 1, 2. Did I disable it by accident? Oh yeah, I did. Tried to put it back in the right button, but I actually put it in the wrong one. 4. There we are. 2, 3, 4. 1, 2, 3, 4. Maybe I've just damaged the membrane enough so that it doesn't work. Maybe there's a resistance thing. Maybe, goodness knows at this stage. We already know it works with 8. Let's get it working. Okay, let's put one end here, the other end here. There we are. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Cool. Awesome. So it is working now. 1, 2, 3, 4. Great. So I think we've established that that's how the Opto thing works. You obviously can solder it or whatever, or do whatever you want. But the key idea is that you get the access to the button, and that you bridge the button using the Opto Coupler, and then you're able to send a signal from the Arduino. And of course, you could do anything you want. For instance, you could change any device into a remote control. You could, oh, I haven't even set that up. Yeah, you can get, there are kits you can get that you can get the Arduino to receive remote control signals. So you can turn anything into an infrared receiver. So that's it. Boy, that is how you hack buttons. That is how you get an Arduino device to hack into and play with devices. Hopefully sometimes you won't need to disassemble the device in order to get it to work, but there you go. So, this has been Sofox with the Arduino Starter Kit. It's been a lot of fun. There's been a lot of cool little things we've done and nice little things that we've learned. And even if you don't necessarily need an Arduino Starter Kit, I mean, even if you just have the raw components and just knowledge and online tutorials and an Arduino, though, you'll still need an Arduino. But yes. Thank you, Arduino, and everyone who makes Arduino, or even that Genuino thing, which was a really weird thing that had me confused for a while, since you technically split into two companies that made the same product and then rejoined. But aside from that, yes, this has been Sofox with the Arduino Starter Kit and playing around with the Arduino. Thank you, hope you enjoyed, and signing off.